Hello and welcome to another episode of Linux and Code. Today's topic is installing and getting started with Git. Now, if you aren't familiar with what Git is, Wikipedia calls it a version control system for tracking changes in computer files and a very long definition. Essentially, what it is used for is keeping track of changes you've made or other people have made to files. There's a lot more that can be said on different Git workflows and different ways to use Git, but today we're just going to cover some essentials and getting it installed and making a few changes to what's called a Git repository with the software itself. Now, unfortunately, on elementary OS, Git is not installed by default. We can do a simple apt install git and we'll have it very quickly because it's a tiny package and shouldn't take much at all to get installed. Now, once we have Git, if you just run it, you'll get the help file printed out because it by default requires some parameters. So what I'm going to first do is move over to a projects directory that I've made because I like keeping all of my projects tucked away and organized in their own folder because it helps keep my home directory clean. So we're going to hop on over here to projects and then I'm going to make a directory for this example repository. So I'm just going to call it git demo and then going to navigate over there. And once we're here, we just have an empty folder. Now, to get started with Git is dead simple. You just do a git init. And what this command does, just as it says, it initializes an empty Git repository in the folder we were currently in. Now, all that is saying is that Git is now set up in this folder. Otherwise, there are no other changes. It's not magically watching for something. Git has just essentially created a configuration in this folder. And what that means is if we do an ls-la again, we now see a hidden folder.git, and that's all the changes we've made so far. Now, if we wanted to get something to be tracked by Git, which is its way of monitoring changes, first we would need a file here. So I'm going to use nano, and I'm going to just make a dead simple text file. So we're just again going to call this sample.txt, and we have a blank file, and we are going to say hello world and write that out and close it. Now that we have this file, if we do a git status, we get a little bit of information here that may look foreign to you if you haven't used Git before. We have a branch, we have no commits, but we do have untracked files. Now, what does all of that mean? Well, a branch is a way to create separate code contexts or code versions within the same repository. So different people use different branches for many different things. A common methodology is to use a branch for a feature or a bug fix so that you aren't fighting with other people trying to all commit code to the same branch at the same time, and that gets to be a mess. Not to say that branches magically solve all of those issues, they still exist, but it's a step in the right direction. Commits are chunks of code or file changes that have been essentially bundled together. And we'll get more into those in a minute. And untracked files, of course, are files that Git sees in this directory, but it has no context for. So Git says, I see these files, but I haven't been told to pay attention to them. So just so you know, they're here, but if you made a change to it and saved it again, I wouldn't care. So how do we get Git to care about this file? Well, that uses another Git command, git add. And There are a few different ways you can use this. A lot of people will unfortunately just use this parameter dash dash all. And what that does is add everything in the current directory that is not being watched by Git or has changes to it to this Git command, essentially. It's just saying take in everything. Well, that can be fine depending on what you're working on, but it is better to be more specific. So instead of doing dash dash all, we can also just pass in a file name, sample.txt in our case, and hit enter. Now if we run a git status, we see we're still on our master branch. We still haven't made a commit, that's important, but we do have a new file that can be committed because we've added it to Git's tracking system. So it just says this is a new file. What that means is we could go and edit our text file again. And save it. And Git would still have this new file status. But it now knows that something isn't staged for commit. Well, what does that mean? We haven't even made a commit yet. So let's talk about that. To make a commit, what would we do? We would do git commit and hit enter. Now, the first time you run this, it's going to produce this error that we're seeing here. And the reason for that is that Git is usually used with a remote repository, and in order for that to work correctly, you need to know who is making changes to what files. It's kind of the basis of how Git works for tracking changes. So we're going to go ahead in here and tell it who we are. And we're just using the commands that it printed out in that error above. And this dash dash global flag we're going to talk about for a minute is indicating that we aren't setting this just for this repository. If we omitted this dash dash global, it would set it just for this repository that's in this git dash demo directory. Using a dash dash global sets it for the Git instance on the entire machine. So I could go create a different repository and go into that, and it would have this same global configuration. So now that we've done that, let's type git commit again and see what happens. Now we get a window that actually lets us tell people or ourselves what changes we've made. So all we have to do here is type in a message. And this window that it's brought up is the default editor for your terminal. And that could be Nano, like it is in this case, or it could be VI or Vim. It really depends. The default for elementary OS is Nano. So all we've done is created sample.txt, and we have given it a bit of text, and that's all we've done. And we're going to hit Control X to exit this, and then just type Y and enter. And we've made a commit. So let's look at that git status again. And it says we still have unstaged changes. Now, what does that mean? Well, if you remember earlier, we added a file and then we went and added extra text to it. So as far as Git was concerned, that file was essentially had a snapshot taken of it the first time we added it. And then it was changed again after that, but Git doesn't know about that yet. It just knows it's been modified. It doesn't know what in it has changed. And the reason that's a useful feature is if you've pulled down a repository and you're making a ton of changes, You don't want anytime you add a missing semicolon or do grammar correction or whatever you're using Git for, you don't want to have to make a message for every single file change that you make. You usually want to bundle them together in a meaningful way. So what we want to do now is include that extra bit of text that we added to our text file. So there's a shorthand way to do this, and it's listing it right here at the bottom. No changes added to commit, use git add or git commit -a. And what git commit -a does is kind of a combination of git add -- all and then doing git commit -m, or depending on if you do -am or just git commit, it's a combination of those two. So we aren't going to do that quite yet. We're just going to still use the basic commands because we're just getting started. So we're going to do git add sample.txt. And great. Now if we do a git status, it'll say we have a file staged for commitment. And now what we're going to do is type another git commit message, but we're going to use a shorthand, which is -m. And that lets us type the message in as an additional parameter instead of opening up an editor. Now, usually a good commit message isn't just a list of files that have changed, it is the intent of changing those files or the reason why. Because Git will have separately a list of files that have changed. The commit message is the logic behind those changes. So now if we do a git status, it just says we have nothing to commit. So where did all of our changes go? Well, we can see all of the changes that have been made to our current branch, which is master in this case, by using another git command, git log. And this is going to print out a list of all of the git commits that have been made to this repository on this branch. And it shows us also where we currently are in terms of version tracking, and it shows previous changes as well. Now this is how Git works. Each commit is given a unique ID. That's what this really long string is. And they're given an author. That's why we had to identify ourselves earlier. And they're given a date. Now, how is that useful to us? Well, it's usually useful if we're working with a remote repository. And the most common remote repository is GitHub. So we're going to open up a new tab over in our browser, and we're just going to go to github.com. If you don't have an account, you can sign up for one. It's completely free and used by a ton of people. There are commercial plans. If you want to know about those, you can go over to pricing. But for public repositories, it's completely free. I already have an account, so I'm just going to go sign in. And now that I'm signed in, you see kind of my dashboard for everything that I have going on with GitHub. Now, this is kind of a side track because we just want to get our project here, our little Git demo, we just want to get that onto GitHub. So it's kind of confusing, but we also have to make a repository on GitHub. So I'm just going to name this the same thing, Git demo. And it's going to check to make sure I don't already have one with that name. Give it a quick little description there. There are a few other options here. I'm going to leave mine as a public repository. And I'm not going to initialize this with a README or a license. I'm just going to create it. Those options can be set to whatever you would like, but you will have additional things you may need to do if you do that. So I'm going to create this, and we get this blank little page with some instructions. Now we have already done this git init because we have already created a repository, so we need to follow the steps for pushing our existing repository from the command line. So we're going to open our terminal back up, and we're just going to follow the instructions they give. We're going to do a remote add. Now, what is a remote? Well, it's exactly what it sounds like. It is another copy of your repository located on a computer other than the one you are using. So it is a remote server. So we're going to do git remote add, indicating that we're adding a server. Origin. This can be whatever you want to call it. Origin is convention for the home of the code, but you could name it whatever you wanted to. And then we're going to give this URL. Now you'll notice this ends in a .git, which is not normally something that you see at the end of a URL. You'd expect either no ending or like a .html or .asp or .php or just something else. .git is not common, but what that indicates is that this URL points to a Git repository. So we're going to hit enter, and it's accepted it, and we can find that by doing git remote ls. Now I've actually misspoken a little bit. It's not git remote ls. It's a little bit different for Git. It's git remote -v. When we run this, we see we get two outputs, but they're both just variants of the same thing, and that's an internal tracking that Git needs to do to know where to push and pull code from, essentially. Nothing you need to worry about for now. But they're both under this origin, and if we had actually just done git remote, it would have just output origin. The -v is for verbose, but it also gives us the URL, which we can see is directly connected to the repository that we created on GitHub. So great. We have a remote, but it's still empty. We've added this remote, but if we refresh this page, it's still exactly the same. So how do we fix that? Well, we do what's called a push. So we're going to do git push, and then we need to specify where we are pushing to. So we're pushing to origin. Remember, we just added that, and we're pushing the branch that we are currently on, which in this case is master. So if we do this, it'll ask us for our GitHub username and password. There are ways to work around this, and it involves doing something called an SSH key, but I'm going to cover that in another video because this is already getting too long. So we've made our repository, and if we refresh this page, we now see our sample text file with the content we made. But more importantly, if we come back to this code tab, we can go to commits, and we see our two separate commits that we made. So this first version will just have our hello world, and the previous version, or the top version, sorry, will have our added change. And you can see this ++ indicating that we added a blank line and added a line of text as well. Now, if this repository already existed somewhere else and we weren't creating it on our own machine, how would we get it? So let's move up a directory and do something a little drastic. Let's remove our directory. And this is going to prompt me for write protected files because Git's trying to protect the folder, but I'm going to force it. You shouldn't do this on your own code, but for the sake of this demo, I'm going to show you how that works. So now we don't have that folder. It's gone. We've removed it. Well, how do we get our code back? Well, if you're either trying to recover code from a repository or you're cloning one for the first time, or sorry, using one for the first time, you're going to do something called git clone. And you use that same URL. We're going to copy that, hop over to our projects directory and do git clone, and then paste. And now, if we run this, and now we can go to that directory again. And by default, whenever you do a git clone, it just creates a directory that is the same name as the repository. So that's why I knew I could go just straight to git demo, because that was also the name of the repository on GitHub, and it's what was specified in this URL. So now if we do an ls, we see our file again. And if we list out the contents of this file, that's exactly what we would expect to see there. Now, that is nice, and for personal projects, that's often enough to get you started with Git. But if you're working with someone else, even just one other person, or kind of want to organize things a different way, there is one other command for Git that will be extremely useful to you. In fact, two other commands. And we're going to get started with the first one, which is git checkout. So what that means is it's checking out a different branch. So, which is essentially a different context of code or different version of those same files. So we're going to do a git checkout, and I'm including this flag -b because I want to create a new branch. This doesn't exist. And I'm going to name it feature/extra files. Now that's just a convention that I like to follow. You could name that whatever you want. So now that we're here, you can see we still have our exact same file. And actually, this is at this point made a copy of the files and their history from the previous branch we were on, which was master. So if we run a git status, nothing will be changed except for the branch, but we still have nothing to commit. Our files are all the same. If we do a git log, we'll have the exact same history. We just now show that our repository is currently pointed to this different branch instead of to master. So how do we use this? Well, let's follow the feature that we say we're creating, which in this case is extra files. So we're going to copy our sample text file and we're going to name it sample2.txt. So we've made a whole second file, and in fact, we're going to also make a .md file for this repository, which is a markdown file. So let's go nano, let's call it readme.md. And we're going to give it a title of Git demo and just a short little description. And we'll save that with Control X and then Y and enter. And if we do an ls, we can see we have 3 files. Okay, great. Let's do a git add, and I'm going to now use the --all because I've made changes to 2 files that didn't exist before, and I haven't made any other changes that I don't want to be included in this. So --all is fine in this context. And now we need to write a commit message. I'm just going to use the full editor this time. And now we want to give a message that conveys the why of these changes. So we're creating a README file, but we already knew that. So why are we creating a README file? Now we've given a little bit more context to this. I'm not going to put anything for sample2 other than to say sample2 is a direct copy of sample.txt. And I'm going to hit Control O to write it out. This is just a different way of saving it, and then Control X to close the editor. Now we get a little message that is essentially a printout of what we just did in the git commit. So now that we've done that, if we did a git status, it would actually say we have nothing to commit. And that's because we've done what's called stage our changes, which means as far as our local Git repository is concerned, everything is up to date and done. But over on our Git repository, our GitHub repository, we don't have any other branch. Go ahead and refresh that just to make sure we're not missing anything. Yeah, still no other branch, and we're still missing our other files. Well, what do we do with that? Well, we still need to push up those changes. So let's do a git push origin, still pushing to this repository, but now we're not pushing to master, we're creating our feature branch. And the great thing about Git is that its command still has tab complete for all of its commands and branch names. That's why I was able to just type F and then hit tab and it auto completed the rest. So we're just going to hit enter. Again, prompt for your credentials. And then it'll push those items up. Now we see that we have this extra branch, and it's offering us to do something called a pull request. And I'm not going to cover that extensively here, but it's a way of merging those changes back with the original branch. We're going to create it. And we're the only one here, so we're just going to go ahead and merge it. But this is a place that you could have added people to comment on your changes, make sure they were okay, not conflicting with anything, run tests on your code. There's a lot of different things that you could do here, but we're not going to get into that in this case. And now, back on our master branch, we have all of these files. So we can go over here, and now we're going to use that git checkout again and switch back to master. But now if we do an ls, our other files are missing. And that's because we merged those changes into master on GitHub, not locally. So we need to pull those changes down. So we're going to do a git pull origin master. And you can see it outputted a lot of stuff. And it's essentially saying our remote repository had changes, just one commit, but it had 2 files in it. That's what this fast forward is saying. And this is what those changes were. So now if we do an ls, we have all of our files. There is honestly a lot more about Git that could be talked about, and I may do a deeper dive video at some point, but this is a nice basic overview and hopefully is enough to get you up and running. Leave a comment if you want me to do a more in-depth dive or if you'd like to see me do a video on something else. Thanks for watching. Hope you enjoyed it. Take care.